Hi, I'm Taylor with the Hach Company. I'd like to spend a few moments with you covering some of the basics of pH measurement. pH is the single most frequently measured parameter, so it's important to follow a few simple guidelines to ensure you're getting the most out of your pH system. Over the course of this video, we'll cover the basics of calibration, measurement, and electrode maintenance. Choosing the right pH electrode for your application will not only help you get fast, accurate results, but it's also a key factor in the expected life of your electrode. There are many electrode design features available, including gel-filled versus refillable, single junction versus double junction, and various electrode reference designs, just to name a few. While we won't go into the specific advantages and disadvantages of each of these design features today, I do want to point out the importance of selecting the electrode that is best suited for your application. Additionally, some electrode designs will last significantly longer in specific applications, resulting in lower operating costs. There are some key things to consider before you even calibrate. Keep in mind that everything you do from this point forward is dependent on how well your meter is calibrated. So let's check a few things before we begin. First, let's make sure the beakers you're using are clean. This helps us to make sure we're not mixing different standards in a single beaker. Next, be sure to check the expiration date on your pH buffers. Once opened, the 4 and 7 buffers are typically stable for several months, while the 10 buffer can drift in as little as 1 month. This is a result of the pH 10 buffer absorbing carbon dioxide from the environment. Also remember, you want to be sure to use fresh buffers every time. Reusing buffers may cause your meter to calibrate incorrectly, resulting in inaccurate measurements. It is also critical to clean your electrode before calibrating so there's no contamination. Now let's discuss the importance of using the correct buffer values for your calibration. Ideally, you'll want your calibration points to bracket your expected sample pH. For example, if our expected sample pH is 8, then calibrating with the 7 and 10 buffer is sufficient. If we expect measurements to fall between 6 and 8, then you should consider a 3-point calibration using the 4, 7, and 10 buffers through your calibration. Always calibrate in the sequence specified in your meter's user manual. If a buffer sequence is not stated, it's best to calibrate from the lowest pH to the highest. Remember, pH is temperature dependent. A simple way to address this is by using automatic temperature compensating, or ATC probes, which will ensure that you have an accurate reading at any temperature. Now we're ready to calibrate our meter. When calibrating, it's essential that you have enough buffer to immerse not only the bulb, but also the electrode junction. The more buffer you have, the less chance you have of introducing contamination. Start by pouring the buffers required to bracket your expected pH result, as we discussed earlier. Second, adjust your stir rate to a slow to moderate setting. Using a stirrer ensures the highest level of accuracy when taking pH measurements and also helps with response time. Next, remove your electrode from its storage solution and rinse it in deionized water. Once it's rinsed, blot the electrode. Be sure not to wipe the glass bulb, as it could influence our calibration and measurement. Once the electrode is rinsed, follow the prompts on your meter. Immerse the electrode in the buffer solution, press calibrate, remove the electrode from the buffer solution, clean it with deionized water, blot any excess liquid from the bulb, and repeat until you have calibrated with all the required pH buffers. Once you have all of your calibration readings, you can record the slope, time, and temperature of the sequence. When you're finished, do not pour used buffer back into the original container, as this will contaminate your buffer solution. Each time you need to calibrate, new buffers should be used. Remember, buffers are inexpensive, but errors introduced to your measurement are not. Now that you have calibrated your meter, it is time to take your measurement. Fortunately, since you properly calibrated your meter, measuring samples should be easy. There are a few things I want you to remember. Just as with buffers, it is important to always use clean containers to avoid potential contamination of your sample. Since we have talked about some of the most common mistakes, the rest is simple. Place your electrode in the sample and press read on your meter. Some meters have auto-stabilization function, which can help with accuracy. This feature locks in your pH reading once the meter decides that the electrode is at its most stable point. Once the reading is stabilized, your meter will lock the reading on your display for you to record. And it's as easy as that. You have taken your pH measurement. Now that we have calibrated and taken a reading, I want to take a minute to talk about how to store your electrode. Proper storage extends the life of your electrode and ensures that it's ready to provide quick and accurate readings in the future. Storage solutions do a couple of things to improve the effective life of your electrode. First, the solution is similar to what is inside the electrode, which helps prevent contamination of the internal filling solution. This is especially important with non-refillable electrodes where we are unable to replace the filling solution. It also ensures that your electrode is hydrated and immediately ready for use. Never use anything low in ionic strength like deionized water, as it will change the internal filling solution concentration and shorten the life of your electrode. We typically find that inaccurate measurements are not due to one significant issue, but a combination of smaller errors. Now that you have learned a little bit about how to properly calibrate, take measurements, and store your pH electrode, our hope is that you can increase the accuracy and precision of your pH testing and make the most of your measurement system. To learn more, please visit www.hach.com.